It would be challenging to find a 3D metal printer that is more magnificent than the one Relativity Space has painstakingly created. This visionary company harbors the ambitious dreams of 3D printing an entire rocket from top to bottom. In just a single month, they can construct a rocket in all its glory, complete with fuel tanks and every essential component. Imagine yourself gazing in awe at the intricate inner workings of a 3D printed rocket. And by the way, this magnificent creation is destined to soar into the cosmos. The colossal masterpiece of metal before you is nothing short of awe-inspiring. Today, we're taking you on a breathtaking journey into the world of cutting-edge rocketry. Relativity Space has just achieved the impossible. They've launched the very first 3D printed rocket, the Terran 1, and we've got all the exhilarating details right here for you. Before we blast off into this epic adventure, make sure to hit that subscribe button and turn on notifications so you'll always be the first to know about the most incredible space news and innovations on this side of the galaxy. Now let's ignite our engines and explore the thrilling story of the Terran 1 rocket. In 2015, a remarkable venture took shape under the vision of Tim Ellis and Jordan Noon. These two smart people, who had worked for well-known companies like Blue Origin, which was started by visionary Jeff Bezos, and SpaceX, which was started by the well-known Elon Musk, decided to make something amazing. The more they worked with metal 3D printing, the more they realized that this new technology could change the way space exploration is done in the future. Their aha moment made them realize that metal 3D printing had a lot of potential for the iterative development of spacecraft and many advantages over traditional ways of making aerospace products. As the two talked, their shared passion and understanding led to the start of an innovative project that aimed to push the limits of aerospace manufacturing and change our ideas of what was possible. On the marvelous day of Wednesday, March 24th, 2023, history was made as Relativity Space launched an extraordinary rocket crafted entirely with 3D printing technology. The beautiful Terran 1 rocket, affectionately called GLHF, good luck, have fun, was getting ready for its first flight at Cape Canaveral's Launch Complex 16. This impressive creation, the largest 3D printed rocket ever to grace the skies, finally soared after two previous attempts had been halted in the week leading up to the launch. During its ephemeral yet awe-inspiring flight, the Terran 1 gracefully achieved two significant milestones: enduring maximum aerodynamic pressure, or max Q, as it traversed the atmosphere with elegance and determination, expertly ceasing the main engine's operation after successfully completing its powerful burn. Alas, the enchanting journey was not without its challenges. The Terran 1 couldn't get into orbit as planned because the second rocket engine was acting strangely. The exact cause of the problem is still unknown, but it is clear that the rocket couldn't reach orbit without the fiery ignition of the secondary engine. Why, you might wonder, would anyone consider 3D printing a rocket? Are we simply driven by our sheer capability to do so? It's rather amusing how your experience with 3D printing led you to the conclusion that, oh, 3D printing is undoubtedly the future. Yet for many people, including myself, the experience with 3D printers has been nothing short of frustrating. It seems that 3D printing is one of those things that promises greatness but often fails to live up to its potential. Yes, during the first couple of years, it had its fair share of trials, which occasionally resulted in nothing more than a heap of metallic debris. Nonetheless, there are compelling reasons to 3D print a rocket. A rocket comprises four primary systems: payload, guidance, structural, and propulsion. Most of the spacecraft is made up of the fuel tanks and the rocket engines that make up the propulsion system. Cryogenic fuel and an oxidizer are fed into the combustion chamber through an injector, where they react and release a tremendous amount of heat. As the gases expand, they rush out of the rocket's nozzle at incredible speeds. By increasing both the exit velocity and the mass flow rate, one can achieve more thrust. Due to the huge engineering challenges involved in making rockets, most rockets have been made the same way for a long time. This means that the tools required to construct the rocket must be developed before the rocket itself. For instance, in order to build NASA's next behemoth rocket, the Space Launch System, SLS, a 170-foot tall vertical assembly center, or VAC, had to be constructed first. This facility is used to weld together the rocket's fuel tanks, which are composed of domes, rings, and barrel sections. Before building the rocket itself could begin, a lot of custom tooling designs had to be made and tested, just like with any other big space project. After 11 years of development, a rocket is finally being assembled on the pad. In stark contrast, Relativity Space has been in operation for a mere 5.5 years, and they launched their first rocket this year. That's why we need 3D printers, which save time and money. That's precisely the world Relativity Space inhabits as they harness the power of industrial robots for 3D metal printing, revolutionizing the way we build rocket bodies. The use of 3D printing, which can create objects with complex shapes using less material, is now replacing traditional methods of manufacturing, which were previously slow due to high costs and lots of material. The time it takes to create a rocket body has been dramatically reduced from a staggering 24 months to a mere 2 months, thanks to this groundbreaking technology. Likewise, the 48-month turnaround for a full rocket assembly has been trimmed to a swift 6 months. The Terran 1 is set to become a workhorse in space that can set up and restock constellations. By using software-driven design and 3D printing, the payload inside the rocket's nose cone can be made to fit the needs of each launch customer. The role of Terran 1 in Relativity's grand plan can be compared to that of SpaceX's Falcon 1, marking the beginning of an incredible journey. Wednesday's launch showcased Terran 1, their debut rocket, which is a smaller sibling to the heavy-lift Terran R rocket and anticipated to be the company's most profitable offering. Priced at $12 million, the two-stage Terran 1 rocket can transport up to 2,755 pounds to low Earth orbit. The Terran R rocket, envisioned to be fully reusable, is designed to carry spacecraft to the Moon and Mars and lift payloads of about 16 times larger than its predecessor. The maiden launch is planned for 2024 as per the company's website, though Brost cautions that the timeline may shift depending upon the data gathered from the Terran 1 mission and subsequent launches. Caleb Henry, a space industry analyst with Quilty Analytics, shared with Forbes via email that Terran 1's position in Relativity's saga is akin to that of Falcon 1 for SpaceX. Testing critical launch technologies with the smaller rocket is essential before the larger rockets, Falcon 9 for SpaceX and Terran R for Relativity, can vie for lucrative contracts in the commercial realm. Despite Terran 1's failure to reach orbit, its potential should not be underestimated. The primary aim of this test was to assess whether the rocket could withstand the maximum dynamic pressure it would encounter during launch, known as Max Q. Additionally, it's not unusual for rockets to fail shortly after liftoff in the early stages of development. Henry points out that launch vehicles tend to have a higher failure rate in their initial years, a fact the industry has become all too familiar with as new rockets from companies like Astra, Avio, Landscape, MH1, and Virgin Orbit have experienced failures in the past 12 months. But there is a big window of opportunity right now, so the sooner Relativity can show that its launch went well, the better. Several well-known companies like United Launch Alliance are getting rid of their current generation of launch vehicles, in part because they can't use rocket engines made in Russia, but their next-generation rockets won't be ready for months or years. Also, the need for more launches has grown because of improvements in satellite technology for low Earth orbit. The phasing out of legacy vehicles, the slow introduction of new launchers, and the growing demand from larger broadband constellations are all putting a limit on the global launch capacity right now, says Henry. The market is ripe for cost-effective, reliable, heavy-lift vehicles that can launch consistently. What do you think, friends? As we stand on the cusp of a new era in space exploration and satellite technology, how will Relativity's groundbreaking 3D printed rockets reshape our journey into the cosmos and redefine what's possible in the world of aerospace? Let us know in the comment box below. That's all for today. Thanks for watching. Stay tuned for more interesting upcoming videos.